All right, theorem 12.2.3 says in a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord at its arc. The idea behind this, it says, okay, so if CD is perpendicular to EF, then that means it bisects the chord, so ED is congruent to DF, and it bisects the arc, so arc ED is congruent to arc FD. The idea behind this has to do with drawing these radii, which we know are congruent. And then being that we know this is perpendicular here, of course, this segment's congruent to itself. So by hypotenuse leg, EC in this point is congruent to FC in this point, which means corresponding parts are congruent, namely this angle and this angle, which makes these arcs congruent, which makes these chords congruent by theorem 12.2.2. And 12.2.4 says in a circle, the perpendicular bisector of a chord is a radius or diameter. So if we know that this cuts this in half and bisects it, that it has to be the radius or extended, it has to be the diameter. All right, so find each measure, find arc CDE. And they took 3 letters to describe this, but CDE really is a minor arc. I could only use 2 letters if I wanted to. Anyway, this is a 18-degree angle, as is this one, because they're vertical. This is 90, so that guy's going to be 90-degree arc, and DE is going to be an 18-degree arc, so adding them together, arc CDE is 108 degrees. 6 wants arc JKL, and again, that's a minor arc, but they use 3 letters to describe it. That's acceptable, it's just not necessary. I could have called it arc JL. And the way I'm going to handle that is I can see JM is a semicircle, which means JKM is 180 degrees. And I got 40 degrees represented here. So if I take 180, subtract from it 40, arc JKL is 140 degrees. Now, what is arc JLN? JLN is going to be the 180 to get me to there, plus an additional 25. So 180 for semicircle JLM, and then arc MN is going to be another 25. So we're talking about 205 degrees. All right, 8 wants arc DF, and again, we can see our diameter here, which means FDC is a semicircle, so I'd go 180 minus, and then arc CD, notice it's going to be 51. So 180 minus 51 is 129. Arc DEB, does describe a major arc, and it is going to be what arc DF was, which we already said was 129, but then I have to add this arc to it, and or basically, you know, it might be easier to think of it as it's all of the circle, but this part, that's how I'm going to attack that. And with this being a right angle, this is a right angle. So that means this is 90 degrees. So you're going to have 360 all the way around. minus 90, giving us 270 degrees. So sometimes it's helpful to see where it isn't and then judge based off of that. Number 10, what's arc JL? Now here we're going to use the fact that HL is a diameter in a line, and the line has 180 degrees, of which this angle is 72 and this angle is 30. If I added 72 and 30 together, I get 102. So these three angles make 180, so take 180 and subtract from it 102, and we're left with 78. So this is a 78 degree angle. No, I didn't want JK. I wanted JL. Either way, I find 78 and 30 to be 108. There was an easier way I could have done it. Maybe you figured that out. You could have just taken 180 and gotten rid of the 72 here and gotten 108. Now what's arc HLK? HLK. That's going to be this semicircle and this 30 or 210 degrees.